Hey everybody, it's Rob with Sine Wave Specialties. Good evening. We're going to go over statics. And you, the hoochies and hotshots of UT, you know this shit sucks. So what we're going to do is we're going to figure out some things so we don't have any particular students freak out on the next quiz or exam or test or whatever. We're going to take a diagram. We're going to do the cross sections. We're going to decide why you are picking certain points for moments. It's consistent with all of them. And we're also going to talk about why there's only a couple moments and then you got this diagonal and then you're summing forces in the y. Well, why sum the forces in the y? We're going to get to that too. We're also going to explain where these numbers are coming from, like FCE at 4 feet. What does that mean? Well, force and dimension or displacement or whatever has a role too. Then we're going to talk about compression and tension and how to identify if a member is in compression or tension. So first one we got 4-16. This is in your book. I'm going to draw the cross section. I'm not going to draw the entire bridge. So we come in here. Ooh, this marker sucks. We got this point. We got an arrow coming out, another arrow coming out, another arrow coming out. Now, this right here has a force here and a force here. We have 12 kilonewtons, another 12 kilonewtons. What we got to figure out is A, B, C, D, we'll go a little bit further, D and E. You will label all the points on the other side of the cross section. Every single, if you cut that beam, you will put the point it's supposed to go to. It's relevant. Why is it relevant? Because of this. So there's that point connected. There's that point connected. Why are these relevant? Well, I'll show you why. First thing I gotta tell you is take the moment. Well, how do I take the moment? Like, why can't I use C? Why can't I use D? I'll tell you why. So what's gonna happen is we're gonna take the moment at one of these things. Now, when we get in here and we do the moments, we're gonna have a force at a distance, plus another force at a distance, plus another force at a distance, and so on and so forth, okay? That's where this equation comes from. We're going to take the moment at some letter, I'll just call it L for now, it's arbitrary. But we have to get as many of these values put in here as we possibly can. We know the distance for all of them, but we don't know every single force in here. So what we try to do, since we have to solve for this one, and this one, is we need to get it down to one variable. How do we get it down to one variable? Well, first of all, you're taking the moment because you're solving a leg for tension or compression. You're not solving it for length, you're not solving it for force, you're not solving it because it has problems. What you're doing is you're trying to solve just one leg at a time. Well, there's 3 legs here. That's why we're going to get into moment, sum the forces. So what you do is you go to solve by going to an intersection point. Why? Because if I have a wrench and I have a bolt right here, I turn the bolt like this, right? Well, if I go into the bolt, it's not going to turn it. If I pull away from the bolt, it's not going to turn it. So if I pick this bolt right here, and there's a force here and a force here, those don't affect that point, which means these will not be in your equation. They're gone. So you pick the point where 2 forces run directly into the point. Take the moment at E. That's the first one. Do your math with all your forces, all that stuff. If it's going this way, it's positive. If it's going this way, it's negative. So these forces are positive because they're driving it counterclockwise. This one up here, BD, negative, because it's driving it this way. It's driving it clockwise. It's negative. Once you take the moment at E, you now have BD right there. So now the moment at E is done. We have F, what it's going to look like is F BD equals some number, either positive or negative. If it's positive, it is under tension. Everything is theoretically under tension because that's what the teacher said. To assume it's under tension, shut up and color. But if it comes out negative and you have a T over here, get rid of the T, get rid of the negative, make a C. T and a negative equals C every single time. Yes, this number is now positive. So if you have -9 in tension, it is now +9 in compression. If it is positive already, don't change it. Leave it alone. Negative, we'll say, is not there to tell you it has a pulling force. What negative is there to tell you is you have the wrong letter. There's a T and there's a C. That's it. Yes, your next one is going to be the moment at B. Why? Because the known and the unknown already go through it. We don't need to know these two. We just want to know CE. But since all these are negated, we just need to know CE. So CE is shooting out in this direction. CE is running counterclockwise. It's positive. So you have positive FCE plus positive 12 kilonewtons because it's the only other thing forcing it to go around in a circle. When you get to the end, what it's going to tell you is it's going to tell you positive or negative. Once again, if it's positive, leave it alone. It's in tension. If it's negative, it's a positive number in compression. So the plus symbol and T go together at the beginning. The negative means you need to switch this C. Once you got that, you got your moment at B, now you're done. You're done. You already found BD, you already found CE. Now you need to figure out this one right here. How do you figure this one out? This is when they go from the moment at some number or letter, and then they do the moment again, and then they're like, oh, well, we're not going to do the moment, we're going to do sum of the forces in Y. That is because this has a Y component and an X component. But it doesn't matter about X because guess what? On this side of the diagram in your book, it's fixed. It's not going anywhere. So the Y is the only thing that matters. Is it upside down? Yeah, it is. Which means this is going to be a negative value. Do not sit here and put, oh, well, this is a 1, 2 triangle. No, this is a -1, +2 triangle. Why do I know that? Because you have the Cartesian coordinate system. That's how you decide positive and negative, okay? This is negative X, this is positive X, this is positive Y, this is negative Y. This is negative, so when you do your cosine, sine, or tangent, you will get the actual positive negative at the end when you do the sum of the forces. Then you will know whether or not it's in compression or tension by the positive and negative symbol. And that is pretty much all I got. So yeah, keep that in mind. You pick a point where two of the unknowns meet. You do the moment at that point to get the one where this guy out here that's fucking off in BFE, this is the one you're solving for when you take this one against it. When you solve the moment at B, you're getting this guy way over here doing its own thing. Positive and negative, positive, leave it alone, it's in tension. Negative, make it positive and put a C in front of it. It's getting compression. The moments or the newtons that go through the point that you're taking are negated. We are not going to use 12. We are not going to use BE. We are not going to use BD. This guy out here, this little guy matters. So this force, this distance away, perpendicular distance, don't go down here and measure this line, measure this way. You're measuring you're measuring perpendicular, the parallel gap. So if you got a force or a point up here and a force over here, you are measuring the parallel gap in between. this distance. That's the distance you're measuring. Now, wow, I got like a big fat blur on it. So, yeah, whatever. The old Pornhub camera sucks. Anywho, but yeah, you're measuring the distance between them parallel. Do not measure this distance here. That's wrong. Measure the parallel distance or perpendicular distance away from that force. So if this is 20 feet, it's going to be 12 times 20 for one point in the moment. And it's going to be positive because it's going counterclockwise. This guy right here, counterclockwise. Now you're measuring this direction because it's perpendicular to this line. So FCE at the length of BC, this distance, multiply them together. You will get a number that will be correct. You do not have to sit there and manipulate it until it looks right and you're going back trying to figure out all the numbers again and go, oh yeah, that's how it's done. Other than that, that's all I got to bring to you. The meeting points, take the moment. The one that's not connected is the one you're solving for forces on that member. Moment at B is going to tell you CE. Moment at E is going to tell you BD. Some of the Y forces will give you this. Since it's not moving this way, but we know it's got 12 kilonewtons at multiple points pulling it down, we have to have the opposite of this force, 12 kilonewtons, and this force at whatever distances they are. And then we have to have another force at a certain distance pushing it up. The sum of your Y will tell you what the whole system is doing to fight gravity and its applied force, which will essentially tell you what this member is. Other than that, that's it.